Well, hello again, and today we're going to be talking about how to solve some radical equations. And there's some certain techniques that you can use for this. Now, and what's nice about this is if you're following along with the Elaine Martin Gabe textbook for beginning and intermediate algebra, if you look on page 626, or at least section 10.6, which is what we're covering today, it gives you a nice 4-step process on how to solve these. So I'm going to elaborate on those as I go through. Now, why would we want to do this kind of stuff? Well, every once in a while when we're dealing with radicals, we need to figure out, we'll have a variable under the radical. And there are times when we'll need to know what that is. I've got two set up here. The one on the left is a lot easier than the one on the right, but the same process applies for both. It's just the one on the right takes a lot more time. But the goal, once again, is just to solve for that variable. Now, the first step that it tells you is that you want to isolate that radical expression there, which means we want to get everything else out of the way. So the first thing that I like to do is get this term to be positive, just because if I'm going to deal with it later, I'd like things to be positive. It makes things easier. So I'm going to add that square root of 1 minus x to both sides. Just like that. So now I end up with x equals -5 plus square root of 1 minus x. Now I still haven't gotten the radical by itself yet, but all I've got to do now is add the 5. And it gets rid of almost all of my negatives, which is why I wanted to go that route. Sometimes you want to look ahead and see where you might end up. Alrighty, so the first step of isolating the radical is done. The next step is that if you remember what a radical is, and it's a rational exponent or a fractional exponent of 1 minus x to the 1/2 power. So if we square it, we can get rid of the radical. And another way to think about this is a little 2 there, because it's a square root. And if we have a 2 here in the index and a 2 out here, they kind of cancel in a way. Remember that canceling really means that they're multiplying to 1. And if I have to do it to the right, I have to do it to the left. It's a property of equality. So I'll have that, x plus 5 times x plus 5. And as I said, those kind of cancel, so we have 1 minus x. And now we at least got rid of the radicals, so now we're in some better shape. So we can use techniques that we've already learned by this point in order to solve this. A lot of us like the term FOIL, right? Got to distribute those through. So x times x is x squared, and x times 5 is 5x. So first, outside, inside, and last. So another 5x and a 25 right there. So we're in good shape. I'm leaving the right side alone for a moment while I deal with the multiplication. So we can add those together. X squared plus 10x plus 25. You probably would have seen, if you've done enough of these binomials squared, you probably would have figured that out without having to do much calculation. But sometimes better just get it down on paper or on a board. Okay, so now we have a quadratic, where before we had square roots, now we've got a quadratic, which means we have to use quadratic methods of solving, which normally means we've got to get one side to be 0. We'll subtract the 1 here. X squared plus 10x plus 24 equals -x, and then add the x. Sometimes you like to put the 1 there so you can see what you're doing. X squared plus 11x plus 24 equals 0. Okay. Now, since this is a little bit near toward the end of the classes that we tend to offer here at TMCC for Math 96, we're probably already comfortable with seeing how to factor these. And the trick is, what numbers multiply to 24 but add to 11? This is the way I like to organize my thoughts. What two numbers multiply to 24 but add to 11? And the very first thought I had was 6 and 4. Well, 6 times 4 is 24, but 6 plus 4 is only 10. So that's okay, they just don't work. And this is what I recommend when I'm tutoring, is to go ahead and write it down and get it out of your brain. Well, if 6 and 4 doesn't work, what if I tried 8 and 3? Because 8 and 3 does multiply to 24, and yes, it adds to 11. So now I can take this up here, and we see this here, right? something that we have learned maybe in 95, where we can get started by putting our x's out here, since that's just a 1, and we put this 8 and 3 at the end. They're both positives, which is good, which means they have to multiply to a positive and add to a positive, a larger positive. And we're almost done. Now we can just break them up. X plus 8 equals 0, or x plus 3 equals 0. Cool. And then subtract the 8, subtract the 8. X is a negative 8, or x is a negative 3 from that subtraction right there. All right, now here's what can get tricky. Unlike some of the other properties of equality that you might be familiar with, when you're squaring both sides of an equation, you end up with something uniquely strange. And that's because sometimes when you square the side of the one side of the equation, you'll get a number that doesn't actually work as an answer. We call that an extraneous answer. So what we have to do is that all the answers that do work are in here, but not necessarily all of them do. So one might work, both might work, but one of them might not. So we want to at least check them, which means we take this answer one at a time and plug it back in. Now, you might be of the pedagogy where you were taught to check every answer, and that's good. It's not always required in all of the math that you're going to learn, but it is required here because of that extraneous answer. So you must do this. So we can try that one first. And it's best to don't check it over here after you squared it, because now that will work. But if you go, so you want to go back to the original equation. So negative 8 minus square root 1 minus a negative 8. I like to put my negatives higher when I've got a negative in front of it, equals negative 5. All right. So I have minus a negative. I'm trying to work from the smallest outward. So that becomes 1 plus 8. So I have a negative square root 9 equals negative 5. And that makes things a little bit easier. So negative 8 minus 3 is negative 5, and now I have a problem. Negative 8 minus 3, that's negative 11. And that's equal to negative 5. Well, that's not true. That is false. So there's one of the extraneous answers, so I can cross that off. You probably will only find one in a lot of the work you do, but we still want to try the other one. So I'll try the 3, and I'll check that one over here. So negative 3 minus square root 1 minus, click off there, negative 3 equals negative 5. All right, same thing as before, negative, negative there, that works out. We can add the square root of 4 with a negative there, with a negative 5 over here. And now that becomes negative 3 minus 2 is negative 5. And that's true, because negative 5 is indeed negative 5. That checks out. So that's a true statement, which means that this is our only answer that actually works, and that's what you would report as your answer. So even though we did all this work, you end up with a square roots, and you ended up creating a quadratic that you're able to solve for 2 answers, although one of them didn't work. So that's not too bad. Now the next problem is a little bit more. So I'm going to start by erasing over here, just so I can leave that there for further notes. So let's take a quick peek at those notes there. It said, isolate one radical, we did that. Raise each side to the power, we did that. We squared both sides of the equation. Have the operation still contain radical terms. We didn't have that, so we were able to move on. Checked all proposed solutions, so we did that. Good. Making sure I'm following along with what I'm saying. Okay, now this time, the first step of isolating the radical, well, which one? That's the question. Which one do we do? Doesn't matter. That's what's nice. You can isolate this one or you can isolate this one. Turns out one's already isolated, so do that one. If you happen to have a square root plus or minus another square root equals a number, get one of them by itself. It doesn't matter which one. So this one's already here. Actually, I'm just going to have to erase this now. This is very easily, in my opinion, one of the longest kinds of problems you'll see in algebra, which means that you can very easily suffer math fatigue and need to take some time with that and work your way through it. But at least the first step's already done. One is already isolated. So we can start with the next step of going to the power of that index right here. So we square both sides. I'm going to do the right side first. I'm going to move my stuff over here a little bit because I know I'm going to need a lot of room. And the square root of something squared is just what's left on the inside. And that's good. Unfortunately on the right, pardon me, on the left, that does not cancel right away. We actually have to take the time because it's a binomial and we have to multiply it to itself. Minus 1, parenthesis equals 2x. All right. Well, now we've got to do the same idea. We've got to multiply those together. Thankfully, if you're multiplying a square root times itself, all you get is what's inside. Outsides. Oh, no, that's not the outside. This is the outside, right? It looks like there's 3 terms here, but there's only 2. Well, negative 1 times this just means there's a minus in front. That makes it a little easier. I like to put my little tail there so I know when the radical ends. Inside, oh, that's another negative. Negative square root. 3x plus 4. And finally, last. Negative times negative is a positive 1. Equals 2x plus 1. Cool. All right, so now what do I do? Well, I've got x terms in common, I've got some constants here, and I've got some radicals. And thankfully, these are both exactly the same, which means I can combine them. So I'm going to combine these first. And remember that when there's a negative there, it's a negative 1. So negative 1 and a negative 1 is negative 2. Square root 3x plus 4. Alrighty, what else can I combine? Well, I've got a 4 and a 1, so I can make a 5. And I can put that 5 anywhere, and I've got a 3x over here. So that step was simply combining like terms. But now I've still got the radical, which means I have to do the same thing again. So get everything on one side and get the radical by itself. So what I'm going to do is I see this radical's negative, so I'm eventually going to move that over to the right with addition because I want that to be positive. It's one of those weird quirks that some people have. So I'll subtract this stuff over first, and then I'll get to that. And as long as I'm at minus 1 and a minus 1. And I'll just do this vertically. That just becomes a 1x minus 2 square root 3x plus 4. 5 minus 1 is just 4. And now I've got a 0. That's good. All right. So I'm just going to add this term over because I want the positives. Some people don't like to deal with negatives, and sometimes you're not going to be able to have a choice, but in this case we do. So I'll add that over. X plus 4 equals positive 2 square root 3x plus 4. I did that with addition. I don't really need that plus sign, I just like to be clear. Okay, we have an option now. Technically the radical is not fully isolated yet because it's still multiplied by 2. But because it's multiplication, and when you square stuff, that's repeated multiplication, right? When you multiply something by itself, or to the third power, you do it 3 times. Since it's already multiplication, and multiplication is you can do them in any order, we can do that now, and it won't change anything. Okay, so unfortunately, we've got another one of these guys. Now, I've already shown it to you twice, so I'm just going to go ahead and go for it. X squared plus 8x plus 16. Because you have the inside and the outside add up to 8. The last multiplied is 16. But on the right, don't forget to do the constant. 2 squared is indeed 4. And this part will cancel, so you're just left with parentheses, 3x plus 4. Okay, so we did that. And finally, our radicals are gone. But we still have to finish the problem. So distribute here. X squared plus 8x plus 16 equals 12x plus 4 times 4, 16. All right. Well, this might work out kind of nicely. I'm going to because the x squared is already positive, we like that x squared to be positive. I'm going to go ahead and leave that alone and move the 12x and the 16 over. I'll do that with subtraction or addition of a negative, however you like to hear it. And since I'm running out of room, I'll come up here. I'm just going to write it again because I don't want to make any mistakes. 12x plus 16, and I'll subtract that and that, so minus 16 and minus 12x. Okay, so on the right side, that's easy, that's a 0. Now that's what was the whole goal when we have quadratics. We need to get a 0 on one side. X squared is unaffected. When you have 8 and you take away 12, you end up with a 4x and a 0. So I'm not even going to write that down. 16 minus 16 is just 0. Which means now instead of a trinomial, we've got a binomial. I did not know this was going to happen. This makes it a lot easier. What's the common term here? Well, we have the x, so we can factor an x out. Okay, which makes this a lot easier. Now, if you remember your what's called the zero product property, or there's some other terms for it depending upon what you like, or the zero factor theorem that the book calls it, means that we can split these up, because if this guy's 0, it doesn't matter what this is, you'll get 0. 0 times anything is 0, and vice versa. So x could be 0, or x minus 4 could be 0. And I'll write my or here. Well, thankfully, that one's already solved. That x came from here. And just because I know sometimes students have a problem with that, you can also write it as x plus 0 times x minus 4 equals 0. You can do that, and it doesn't change any of the math here, but at least now you have the binomial that you're used to seeing when you do these problems. So you get this, and you end up with x equals 0 anyway. So that's just something for you to feel better about. And then add the 4 here. So x equals 4. And I'll bring this down. X equals 0 or x equals 4. All right. Well, once again, though, we have two answers. They both could work, maybe, but we don't know for sure. So let's go ahead and plug them in and find out. 0 is always an appealing number to choose because it tends to cancel a whole bunch of stuff out. So I have to go all the way back to the original problem. I'm going to write it down without my notes first, just because I don't want there to be any confusions. All right, so I'm going to plug in the 0 first. So 3 times 0 plus 4 minus 1 equals square root of 2 times 0 plus 1. Well, thankfully, that just becomes square root 4 minus 1 equals square root of just a 1. 2 times 0 is 0, plus a 1 is 1. Alrighty. Well, the square root of 4 is 2 minus 1. And sometimes students get kind of, it's really simple. So it's so simple, sometimes students make mistakes. Square root of 1 is just 1. Works that way. Which means 1 equals 1, it works. All right, so that one definitely is, oh, wrong one. That one is definitely an answer that works. Okay, so now we'll try the other guy. So that was one check. I'll do another one. We'll put the 4 in for the x. 3 times 4 plus 4 minus 1 equals square root of 2 times 4 plus 1. Okay. 3 times 4 is 12, plus 4 is 16. Minus 1 equals a square root of 8 plus 1. 8 plus 1 is just 9. All right. Well, the square root of 16 is 4, minus 1, equals the square root of 9 is 3. And that which means 3 is 3. Which means that worked out, which means this also is an answer. So we did not have an extraneous answer this time, which is really cool. That also means that if you're a graphical and visual person, now this is just a kind of a sketch, so don't graph this directly. It means that at some point you had one graph that kind of looked maybe like this, another one that maybe looked like this, but it had to have crossed twice at some point in order to get that to happen. In that case, it would have been 0 and 4, though, not like 1 and 5 like I drew it. So yes, so that's your basic technique. Once again, first step, make sure you isolate a radical. And then do the power to both sides of the equation to try and cancel out that power, and do some algebra there and clean stuff up. If you have a radical again, do it again. This is, once again, is a very long problem. So just take your time with it. Don't get in a rush, in a hurry, and don't get frustrated over the time commitment. And then after you solve that, you'll end up with a quadratic most often that you can solve. And then just make sure you check your answers when you're done. All right, that's all I have. Thank you very much.